All right. Let's see. It's roughly 2 minutes already. All right. That's letter B. All right. So let's see. Now there are some calculation that you might have to do. So just be aware of that. Yes, you do have those kinds of technologies in SAT. But I think that you're better off to sometimes write things down on a piece of paper. All right. Now, first off, we are looking at the total number of students, right? For elementary school, middle schools, they say that there are twice as many elementary schools than there are, middle schools, right? But we realize that total students, number of students is 150. So that means we could figure it out. The letter C. Oh, sorry. I'm glad I noticed right away. Okay. So the letters C and the F, right? Because that represents the total number of students in elementary schools versus the middle school, right? Now 150. What kind of number of C and F should we have? So the number of elementary school students are twice as many. 150 total, right? So the elementary school student has twice as many as the middle school. Yes, right? Does it make sense? Or just, I mean, usually they have those numbers that are easily, partitioned in such a way, right? So we figure that, what, this is 100, right? That's 50. Okay, so now they say 60% of elementary school students taking a bus. You see why they have the 100, right? So it'll be easy to calculate. So A stands for the number of elementary students taking the bus, right? So that got to be 60, right? 60 out of 100, 60%, right? So that leaves you how many students in by walk? Well, you probably don't even need that, but let's just put it there, right? 40 students, right? So now, hey, they say that in total there are 80 students taking bus. 60 of them are elementary school students. That means there must be 20 middle school students, right? Okay, now we can figure out how many middle school students are walking to school, right? Total 50 middle school students. 20 of them by bus, 30 of them by walk, right? That's all. So it's very logical. But of course, if it will take you some time to realize there are 150 total, so twice as much, for elementary school students. So 100, elementary school students, 50 middle school students. Then later the percentage. If you tend to have some, hard time with percentage, those are the questions that, maybe look up, those kind of questions from the website called One Test Prep XYZ. Well, let me show you that real quick. One prep, sorry, my bad, not one test prep. One prep.xyz. That's a digital question bank, right? So you can go into the question bank and find maybe proportions, percentage, right? Any kind of questions, trick, right? Start working on them. You can choose the difficulty level. And I've been talking to a few students who came by, for the first office hour visit. I said, now Friday morning is the best time for you to come by and get some assistance, especially about those questions that you've been getting wrong, even after checking the answers, because those questions come with answers. You can try them and later check the answer, not just answers, explanation. If you still don't get it, or you feel like that, I'm always going to spend so much time on these kind of questions. Those are questions you're going to come by Friday morning, talk to me, or even have a little group of students study together, share your thoughts, right? If you had a hard time with this kind of questions, now you figure it out. That's my little trick, right? And I think that this is probably better than any kind of physical, test prep books, right? Or even the packet that I share with you on D2All. It's physical, unless you're like a big fan of like a paper medium. I think that this is, if I were a student, so I'm definitely gonna use that, right? Anyway, now back to SAT prep. So the answer is letter B. Now let's see which question I'll feel like that you guys could take a look. Let's go back up to 17. Now, before you try it, does anyone remember how you divide polynomials? And let me remind you those the terminology. All right. Have you guys heard of the long division? Wait, did we do the long division last semester? Okay, so it's not in college algebra. So algebra 2, right? Okay.
My teacher never taught me.
Really? Okay. Okay. I was gonna say glad to hear, but it's not a good thing to hear. Anyway, so let's try it. How about that? Now let me copy this problem. Because I do need some space to write it. And I do want you guys to seriously take notes. Now the good news is, in general, things are, oh, come on. It doesn't work that way. Okay, anyway. Whoops. Okay, 4x squared minus 3x plus 2. 4 x squared minus 3x plus 2, right? And I need to divide it by x minus 3. So thank you. Hey, Dr. Aiken. Okay. Yeah. Probably not right now, but I'll be happy to do that. Maybe stop by during my office hour, or maybe usually Friday morning from 9:30 to 11:30. That's what they call Friday care, right? So that's the general tutoring hours. Yeah. Yeah. Sure. Yeah. Give me a second. Are you guys seniors?
Yeah.
See when that's my last name, right? See when 3. Cool. All right. So the polynomial 4x squared minus 3x plus 2 is called a dividend, right? And the x minus 3 is called a divisor. So do you see that we could write things like that in the same exact way that you used to do maybe in elementary school, right? The old-fashioned division sign, right? You probably haven't seen it for years. And turns out that the algorithm, or the way you do in the division, is exactly the same as you did back then with pure numbers. Okay. So let me remind you how that works out with numbers. So then you will see that it's the same. Let's come up with some big numbers. Maybe, I don't know, like 107. Just make that up. Divided by, let's go with maybe 6. Right. Now, the division, you go by digit, right? First, you see that, okay, does the 6 go into, wait, is that how to say it? Does the 6 go into the 1? Not really, right? 1 is not big enough, right? So you're going to have to do the first 2 digits, which is 10, right? So does 6 go into 10? So the quotient is going to be 1, right? And now you're going to multiply the quotient of 6 to see, oh, I'm only getting 6, right? So what's left over is the difference, right? Which is going to be 4. So now you're going to bring down the next digit, right? So do 47. So now you do it again, right? 47 divided by 6. Would that be 7 as well, right? Because 7 and 6 is 42, right? So you do 42 and see that, you know what? Yeah, the quotient is 7, but unfortunately, you still get something left over, which is 5, right? Now, should I keep on going or should I stop? But how will I be able to go if I don't have anything to pull down anymore? And then 5 is even smaller than 6. So you stop, right? And what do you call the 5? Remainder. Yes. Those bad experience in algebra 2. Right. And the 17. I mean, I taught algebra 2, I taught trig, and I taught even regular algebra. I know how. Anyway, 17 is the quotient, right? So now let's do the same exact thing, but now you have to be open to polynomials. You also go by terms, not digits, terms, right? So there are 3 terms starting from the first term. And here's the weird part. You don't divide the first term 4x squared by the entire divisor. You only go by the first, the leading term in the divisor. So it'll be 4x squared divided by x. What do you get? You still get a 4, right? X squared divided by x, you get x. So now I want you to line up that part of a quotient, which is 4x, with the term in the dividend that has the same exact power of x. It's not something you have to do, but you'll be benefit from doing that because your work will be so organized, and you'll see if you do make a mistake, you'll be able to catch it right away, right? So one, it again? Yeah, so just like, you go back, right? So now you're going to have to take the -3 as part of the dividend. There's a division, divisor, right? So you multiply the divisor with the part of the quotient to recreate part of the dividend. And let's see the difference, right? So 4x times x, you get 4x squared, right? And that has to be like that, right? If you don't get 4x squared back, that means you did something wrong with the quotient. The second term, 4x times -3, so you get -12x, right? So now let's draw a line, and now we did already, and that's how we got the 4x. But now, remember, how did I get that 6 in the second row? I multiplied a 1 and a 6, right? And what I did in the second row here is to multiply part of the quotient I just figured out with the divisor. But unfortunately, I have to distribute a 4x, right? You see it? No? Sure, yeah. But basically, the second line here, I got the first term by multiplying 4x and an x, right? I got that. And the second term, the reason why it's negative is because I multiply 4x with a -3, right? It's a term by term, right? So now, you need to find the difference between these 2 lines. What do you think will be the difference? Just subtract, right? So those 2 things are gone, right? So here's the tricky part. If you subtract -12x from -3x, what do you get? Be careful. You're finding a difference between these 2 guys, not adding them up. You subtract them. Now, if you're not used to doing that, in your head, write it down. -3x, right? Subtract -12x. Okay, so now you lose the parentheses, and it's the same thing as -3x plus 12x. And you're getting 9x, right? Am I right? Do you see that tricky thing? So people can start making mistakes as soon as the second line. All right, so you're getting positive 9x. And what do I do next? Bring that 2 down and start over, right? But this time, you're going to start with the first term here instead of the 4x squared because that has been taken care of, right? So 9x divided by, not the whole thing, but just the x. So 9x divided by the x, you get a 9, right? So I'll put the 9 right on top of the 2 so that you see that everything vertically lines up, and these things all have the same exact power of x. Well, you might say, well, there's no x here because x is raised to the 0th power, right? That's the quadratic term, linear term, and constant term. All right, so now don't forget you have to go back, right? Let's check by multiplying 9 and x. So you do get 9x, right? By design, but trust me that this has to work out, but not necessarily the second term. 9 times -3, you get -27, right? So now again, you're not adding these up. you find the difference. Subtracting negative 27 from the 2, so you're getting positive 29. Yes. And should you stop? Yes, right? For two reasons. First off, there's nothing you can pull down anymore. Not to mention that this is in a lower order than the divisor. When I say the lower order, I mean the degree. This is what we call a 0 degree term because it's x to the 0th power. It's constant. Okay, and that's a first degree divisor. You stop when you get something that is lower in degree than the divisor. We didn't stop when we get to 9x plus 2, right? Why didn't we stop? It's the same degree as the divisor. You can do one more round. Okay, so now the way you put it, so now this kind of question is asking you to do division, right? So the question was, how much is 4x squared minus 3x plus 2 divided by x minus 3, right? So your answer to that kind of question is equal to quotient plus remainder over the divisor. So put that in such a form. All right, so let me zoom out a little bit. All right, so you're gonna put, all right, sorry. So the quotient is gonna be 4x plus 9, right? The remainder is gonna be 29 over the divisor is gonna be x minus 3. Say it again, which part?
The 9x is 1 to is that right?
Well, the negative 3 times the 9, right? Oh, I see what you're saying. I got this line by multiplying the second part of the quotient I just got, right, and the divisor. And I do it turn by turn. That means the 9 gets dx, that gets you 9x, right? Oh, sorry, the other one. No, sorry, look at the wrong thing. Come on. Can I just drag it? Oh, there we go. Yeah, and then you see that the second term was coming from 9 gets multiplied by not 3, but negative 3, okay? But hey, that's SAT. You don't have that much time to probably do a problem like that, right? Unless you just practice for so many times you're getting quick. So now, if you're already taking a picture, well, remember that this is recorded. Let me go back and let's see. Is there a way if you have to figure it out within a minute which option to pick, and you have all the resource, right? Graphing calculator, decimals. What would you normally do? Figure out a question like that. Okay, where are you gonna plug in? Okay, so now you can tell me if that's what you're saying. So you wanna type in the decimals. This guy divided by that, right? Type it up. It's gonna show you a graph, right? And how do you know which one to pick? We're gonna go through these options and just type it all in to see which one matches, right? You could do that. You know what? It will be even faster if you just try a number for x, right? Because I think that it's quicker to type number instead of the x's. But like you said, that I think that it'll worth trying, within a minute or two, just to plug in stuff, right? Yeah, good. So I like that. So the answer is D. Now another one is number 15. Oh, let's take a look. Why is it an angle?
Yeah.
Oh yeah, well, I don't know. They scan the front of the book. All right, go ahead. I'll give you 1 or 2 minutes for number 15. Go ahead. And remember that as if that you're taking SAT, so you have the decimals. To know how to use the decimals to figure it out, give it a try, and maybe share with us how you did that. Right? I think that not everyone's now, quick with using decimals. But trust me, it can still be worked out with pure algebra, and it's even not that hard, well, to do it by hand. But I would like to show you both ways. Okay, it looks like the inequality sign is kind of troublesome to deal with. What if they're equations? You could, because you see that they say, hey, when the y is reaching its greatest possible value, will be the x, as if that they're asking you just to look at the equality instead of the inequality, right? But yeah, that's something we'll look into. Now, anyway, number 15, the answer is letter C. You guys figure it out? Letter C, number 1. Okay. So now, anyone worked out by hand? Oh, okay. Anyone worked out using decimals? All right, Razia, how did you do that? Great. No, do you mind if I hold it up? So, guys, you see that it's literally just type it into the decimals. You can even type in, not just equation, the inequalities. And do you see why they're shading the regions? One of the lines, let's say, y. First one, y is less than or equal to x plus 2. Now, that I think it's the green line. They shade the gray region so that this is the region wherever you're going to put the points for x and y, they will satisfy that inequality. And when do you think that equality is reached? It's on the edge. It's on that line, right? Y is equal to x plus 2 will be the edge. And that intersection tells you where the y has to be at the maximum, because you're looking at the overlap of these two regions. All right. You see that, I don't have to tell you any more detail. When you see a graph like that, you'll see right away. You can even click on that maximum point to see y is 1, x is y is 3, right? Y is 3, x is going to be 1 to get to the y. Okay. Now, that's the decimals. So let me show you algebraically how that works out. So I was talking to the student just now. I said, what if these two are equations? Y equals to x plus 2. Y equals negative x plus 4. So you're asking you to solve for x, right? How would you do that? Okay, you can make them an equation by setting them equal, since they're both equal to y, right? And that's called substitution, right? That works. Or, you know what? I'm so used to adding things up, when I see that x and negative x are opposite each other, if I add up these two equations, I get 2y, right? X are cancel, 0 plus 6, and y must be 3, right? So now if you take the y back into empty equation to find out what x is, right? So now you tell me, what if these are not equations? So I'm going to put less than or equal to over here. Does the whole reasoning still hold? It does. Because it turns out that the property of inequalities protected us, right? by adding the same thing on each side, the inequality still holds. That means you can still do that as if they're equations. But now you see that you're going to interpret this result a bit different. Y is not necessarily equal to 3, but y cannot be greater than 3, right? Its maximum is going to be 3. That's exactly what they're looking for. When you're going to reach the 3, 1 equal to 3, y has to be, well, x has to be 1, right? Anyway, now that's number 15. Oh, I have another one. So since you guys just learned a lot of things about trig, especially the radians and degrees, I think that you guys are going to like this one. 14. All right, go ahead. 14. Huh? Seems weird, right? The way they ask you. You got it?
Am I crazy?
No. Good. So now you see that some of the angles that you're probably gonna now, like Kim, if he keeps doing the conversion from some of the radians and pies, right, into degrees, you're probably gonna remember. Oh, you know what? 2 pi over 3 is gonna be whatever degrees, right? So just kind of start to remember them. Yeah, that's the way to go. All right. Anyway, the answer is 3. So basically, just saying that how many of those angles are there in a whole circle, right? Because 360. Now, so maybe a lot of you are, big fan of degrees, right? So you're probably going to turn 2 pi over 3 into degrees by multiplying 180 over pi, right? And you're going to get 120 degree, right? So how many 120s are there in 360? So there were 3 of them, right? But I mean, if you're okay with radians, why don't you just turn 360 to 2 pi? So you're basically asking, hey, how many 2 pi over 3 radians are there in 2 pi? You're going to take 2 pi divided by 2 pi over 3, right? And I'm sure that you're going to turn that into 3, right? Either way, right? So if you get it right, there's nothing wrong with however you do it. All right, so that's number 14. Number 13. So that's a percentage problem. So that could, in general, sometimes be a bit confusing. And it seems a lot of redundant information. All right, so give it a try. 13. Oh, sorry. All right, is that good enough? All right, see, the answer is letter B. Okay. Now, if you seriously calculate, which is totally fine, and I will prefer you actually do that at least once, right? So now after understanding what they're telling you, so this guy take 300 milligrams right, of calcium that gives only 23% of the daily amount, right? And later on, by taking a bit less, right, will be the percentage of the daily amount. So you can find out the daily amount of calcium suggested, sorry for the handwriting, daily amount, right, is 300 divided by 23%. Okay. Now, so I guess that sometimes, people might be confused that do I multiply this with 23% or divide it by 23%? So as I typically, remember this, should the daily amount be more than 200 grams or not? So this guy takes only 200 milligrams, and that contributes only 23% of the daily amount suggested. So the daily amount should be more than 200 milligrams, right? That's why if you multiply 200, with 23%, you're gonna get smaller, right? You're gonna get a small amount. So the only way to do it is just divide, right? So you're gonna get a bigger number, right? So you figure out what that is. So now once you have 210 milligrams, right? So the new percentage will be 210 divided by whatever you figured out by dividing 300 by 23%, right? And you're getting roughly 16%. Well, actually, you're getting a decimal, right, which is 0.16. You turn that into 16%. Okay.
Is it okay if I did like a ratio? I did 300 over 0.23.
That's well.
10 over x.
Okay. Oh yeah. So proportional, right? Yeah. Perfect.
And then I
That's another way. Yeah. So Noah's ways is actually the algebra way, right? Just set up the equation, solve for the unknown, right? So what I did was just talk through the logic, and if you understand it, that's a different way. I think that his way is actually more reliable, right? Just make sure that yes, right. Good. That's something I'm gonna tell us what you do. Right. Uh-huh. Yeah. What's even nicer is sometimes I see those questions might have two options or even easier to eliminate. So here, you kind of have to think that is 20 smart enough, or what if they make it like a 26%? And they're gone right away, right? They're gonna see, well, it's not gonna be 8%, right? It's only dropped by, like 100 grams or something, right? There you go. Yeah. I think that, by going through the options, think about what might be the absurd options, just rule them out right away and go with the more likely one is the best way, right, for SAT multiple choices. Okay, good. Let's see, we have time for maybe one more. So now let's see if you guys are able to use the tricks you've learned in this semester to figure out a geometry problem. You may not need the trick, but I wish that you can use it. All right. So 12, right? So that will be the last question I'm going to have you try. Number 12. Please, if you can, use the trig function, sine, cosine, tan, whatever. All right, so number 12. Let's see what is that? All right, it's letter A. Raise your hand if you've used the trig function. Okay. And without trig functions, you know, maybe back then, what do you guys do? The special triangle, right? Or doing the ratio kind of stuff, right? Or yeah, so I get. So now let's see. Let me put it down so I know that you know, you guys get it now, but you know, just in case that you want to refer to it. So you have 10 units for EF. All right, and so we have an angle here, which is 30 degree. And you're looking for now in this right triangle, this is 10, that's 30, right? You're looking for the question mark, right? That's the adjacent side of a 30. So now what you do is just recall which function, right? Usually it can be sine, cosine, or tangent that relates the adjacent and hypotenuse. Cosine, right? Cosine 30 degree is the question mark, right, over 10. So now you're solving for the unknown by multiplying 10 on both sides. So the question mark better be 10 times cosine 30. Oops, cosine 30. So now, of course, you know, since you just took the test, I'm sure that almost everyone remember the cosine 30, which is not 1/2, right? It's radical 3 over 2. So that's why it gets you 10 times radical 3 over 2. So that will be 5 radical 3.